Today we're doing section 1.2, functions and graphs. A function is a correspondence such that each member of the domain corresponds to exactly one member of the range. So we're going to take a look at a few examples. The easiest thing to look at is a set of points. When you're looking at a set of points and determining if it's a function or not, you want to look and see that all of the x values are different. Okay, so let's take a look at a few. So I've got 2, 3, 8, 9, 10, 20, okay, first of all, in the homework, they are going to ask you to identify the domain and identify the range. The domain are all the x values. So in this one, our domain is 2, 8, and 10. And our range is the y values. So 3, 9, and 20. Okay, and looking at this one, our x values 2, 8, and 10 are all different, so this one is an example of a function. Okay, we'll look at it just a few more. I've got 1, 8, 1, 3, and 6, 7. Okay, well, for this one, right away, we see that we've got two x values that are both 1, so this one is not a function. And we'll take a look at one more. So I've got 1, 8, 2, 8, and 3, 9. Okay, well, we need to be careful with this one. If we look at all of our x values, all of the x values are different. So that tells you right there that it's a function. Some of you might look at the y values and notice that they have the same y value, but that's okay. It's still a function. Okay, so all of the x values just have to be different. And let's go ahead and identify the domain and range for this one as well. Okay, so the domain, we've got 1, 2, and 3. And the range, well, we've got 2 8s. You don't have to write down 2 8s. If you just write down 8, that covers it. And then we've got 9. Okay, they might show this to you in different ways. They could show you what's called a map. Okay, so let's take a look at another example. I've got 1, 2, 3, 9, 16, 18, and they'll tell you which value goes to which. So in this one, the 1 is pointing at the 16, the 2 is pointing at the 9, and the 3 is pointing at the 18. The first column is known to be the domain. The second column is known to be the range. So remember, to be a function, each x value can only go to one y value. Okay, so really you just need to look at the x's again. If all of the x's only have one arrow coming out of them, then they're only going to one value. So this one is an example of a function. Okay, another example, I've got 4, 5, 6, 1, 2, 3. 4 is going to 1, 4 is going to 2, 5 is going to 2, 6 is going to 3. Okay, right away we can see that one of our x values is going to two different y values. That right there is what makes it not a function. Okay, the y value 2, having two arrows pointing at it, is okay, but the fact that we have one of our domain values pointing to two different range values, that's what makes it not a function. Okay, finally, they might give you some graphs. Okay, and we use what's called the vertical line test. If we can draw a vertical line anywhere on the graph and it only hits that what's being graphed once, then it is a function. Okay, so let's take a look at a couple examples of those. In this first one, we just have a circle. Okay, well, if we draw a vertical line, just right there, right away already it's hitting 2 spots on that graph. That means it's not a function. Okay, it can only ever hit at most once. Let's draw another one. This one's just a line. Okay, well, if we draw a vertical line anywhere, it only ever hits at most once. So this one's an example of a function. Okay, so now we've determined how to figure out if it's a function or not. There's a few different problems that we can do now with our functions. Given g of x equals 3x squared minus 2x plus 1, we're going to find the following. First of all, they just want us to find g of 3. Okay, well, this is function notation. This is the function name, g, and this is the input. The x is the input. So whatever they put in the parentheses here is what they want you to plug into the equation. So in this first one, we've got 3. So we're just going to plug 3 in wherever we see an x value. So we've got 3 times 3 squared minus 2 times 3 plus 1. Okay, and do your order of operations. So we'll do this squared part first. We've got 3 times 9. Okay, and then we'll multiply. So we've got 27 minus 6 plus 1. And finally, we can add or subtract left to right, and we'll get 22. Okay, then the next one, they give me g of h minus 2. Okay, well, it doesn't matter what they put inside the parentheses. They're still telling us to plug this in for our x. So we'll plug h minus 2 wherever we see an x. So we've got 3 times h minus 2 squared minus 2 times h minus 2 plus 1. Okay, we're squaring first again. We've got a whole quantity squared, so remember what that means. That means you're multiplying it times itself. So I'm going to write that out. I will remind you of a shortcut here in a few minutes. Okay, and then we're going to go ahead and FOIL. So I've got h times h, which is h squared. H times negative 2, negative 2h. Negative 2 times h, negative 2h. And negative 2 times negative 2, positive 4. Okay, then let's go ahead and simplify inside here. We'll add out those like terms. So we've got h squared minus 4h plus 4. Okay, and before we finish this one up, I just want to remind you of the shortcut. We could have gone directly from here to here if we remembered the shortcut. So when you square something like this, you're squaring the first term, which gives you the h squared. To get the middle term, you multiply these two terms together and then multiply times 2. So h times negative 2 is negative 2h times 2 is negative 4h. And then you square that last term, 4. Okay, so whichever is easiest for you. If you remember the shortcut, use the shortcut. If you want to just write it out and multiply it out, go for it. So we're going to go ahead and finish this up, distribute. So we got 3h squared minus 12h plus 12 minus 2h minus 4 plus 1. Okay, let's add up the like terms. So we've got some h's here. So we've got 3h squared minus 14h, and then we have some constants. So that'll give me a plus 9. Ah, I see what happened. Okay, so it's not a plus 9. We've got a negative 2 here. I did not distribute the negative. This negative 2 times negative 2 should be a plus 4 right here. So we've actually got 12 plus 4 plus 1, which gives us 17. Okay. We can also find the values off of a graph. Okay, so we're going to find the values looking at this graph. And they give me the points 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. Okay, and then they just ask, what is f of 1? Okay, well again, they're giving you the input. This is the x value. So we'll go over to the graph and look for the x value of 1. We have that right here. Well, what is the y value at that point? Well, the y value at that point is also 1. Okay, so they're giving you the x value and asking you what the y value is. So we've got f of negative 2. Okay, well, we'll go to where our x is negative 2, and then our y value there is 4. Okay, so in the second to last example, we're going to find the domain. And they give me f of x equals 5x plus 1. Okay, well, when they give you a function and they're asking you to find the domain here, they're asking you what can you plug in for x and still get a real number back out. Okay, well, look at what's happening here. We're multiplying times 5 and we're adding 1. If you plug any real number in, you can always multiply it times 5 and get another real number, and add 1 and get another real number. So it doesn't matter what we plug in for x. It's always going to work. It's never going to be undefined. So this one, the domain is all real numbers. Okay, let's take a look at another one. We've got f of x equals 1 over 3 minus x. Again, you're asking yourself that same question. What can I plug in for x? and get a real number back out. Okay, well, we have to be careful in this one. We've got a denominator in this one. What can't we have in the denominator? We can't have 0. That makes it undefined. Okay, so go ahead, set your denominator equal to 0. You might be able to see it right now anyway, but solving that equation will tell you what you can't have. Okay, so we're going to subtract 3. And divide by -1. Okay, if we plug 3 back in for x, we're going to get 0 in the denominator. That's going to make it undefined. So it's all real numbers except for except for 3. So you can write it all out in words, or you can write it in set builder notation like I did here. Okay, and looking at our last example, again, we're going to determine the domain and range. But now we're going to determine it off of a graph. And in this graph, they give me an open circle at -2, -1, and a closed circle at 4, 1. And they ask for the domain and range. Okay, well, just remember, what is the domain? The domain is all of the x values. So we want to see how much of the x values are covered by this function on this graph. Okay, so if we're looking at the leftmost that we can go, we're at -2 here for the x values. It's an open circle, that means it's not included. So we're going to put parentheses for an open circle. We're starting at -2. Notice it's connected all the way until it gets to this furthest to the right point. So we don't have to stop anywhere in here. All of these x values are covered until we get to 4. And there's a closed circle at 4, so that means it's included. We can put a bracket. Okay, the range is our y values. Our y values, well, we know this is the y-axis, so it's as far low as you can go and as far high as you can go. So this is our lowest value right here at -1. Again, it's an open circle, so we have to put parentheses, -1. All of the values in between are covered. This is our highest value up here, and that's at a y value of 1. And it's a closed circle, so again, we'll put a bracket. Let's just take a look at a couple more graphs. This one, I simply put a horizontal line at 5. Okay, well, if we're looking at the domain is our x values. Well, notice that we start -infinity. It keeps going to the left. We keep going to the right, and everything in between is covered. So all real numbers for the domain is covered. So we can write -infinity to +infinity. The range, our y values. Well, the only y value that we hit is 5. When you've only got one value that you're hitting, you can use those squiggly brackets and put that we've got 5. Okay, one more. We've got a parabola in this one. Notice I didn't even bother writing down any numbers because we can see the important value right here 0. If we look at our x values, again, we go to the left, we go to the right, everything in between is covered. All of our x values are covered. So all real numbers for the domain, negative infinity to positive infinity. The range, well, our lowest value is 0, and then we do go up to positive infinity. So we're going to start at 0, go to positive infinity. Notice I put parentheses whenever I put infinity. And then our 0, there's a solid line hitting that 0. That means it's included. So we'll put a bracket there. Okay, and that was the last example. So go ahead, check out the notes, and check out the homework.